There is a planet spinning in the dark right now where rain falls as solid rock, and the ground underneath is a glowing ocean of melted stone. Scientists did not expect to find weather at all on a place this violent, let alone a weather cycle that looks strangely like the one outside your own window. Stick around because by the end of this video, you will understand exactly how a planet can have wind, rain, and oceans made from something that would melt a steel factory. Before we go any further, if strange worlds like this one make your brain light up, tap subscribe now so stories like this land in your feed the moment we publish them. The planet is called K2141b. It is not science fiction, and it is not a special effect from a movie. It is real, it is out there right now, spinning quietly in the dark, and NASA scientists have spent years trying to fully understand it. This is not a gentle, rocky world like Earth, and it is not a giant ball of gas like Jupiter. It is something in between, something that should not really work, and yet there it sits, spinning around its star at a speed that will make your head spin too. Picture a planet so close to its sun that one full year, one full trip around that star, takes less than 7 hours. That means if you lived there, you could watch an entire year go by in less time than it takes to sleep one night. That kind of closeness does something terrible to a planet. It cooks one whole side of it until the rock does not just melt, it turns into gas and floats into the sky. By the end of this story, you are going to understand rain that falls upward in your imagination, even though it is really falling down, oceans that glow instead of splash, and wind speeds that would flatten every building on your street in seconds. This is one of the strangest places NASA has ever laid eyes on, and almost nobody has heard its name. That is about to change. Now let us start from the beginning. Most people believe that a planet close to its star just becomes a hot, dry version of Earth, like a desert with no water and nothing interesting going on. That is the wrong picture. Being close to a star does not just make a planet hot, it can completely change what the planet is made of on the outside, turning solid ground into something closer to a boiling pot on a stove, except the pot is the size of a whole world. To find K2141b, we have to go back to a NASA spacecraft called Kepler. Kepler launched in 2009 with one simple job: to stare at a patch of stars and watch for tiny dips in brightness. Each little dip could mean a planet was passing in front of its star, blocking a sliver of light, the same way your finger blocks a small bit of light from a lamp if you hold it up close. Kepler was supposed to be one of NASA's quiet success stories, not a headline mission. In 2013, 2 of the wheels that kept the spacecraft pointed steady broke down. Engineers back on Earth thought the mission might be finished for good. Nobody expected much more useful data to come from a broken telescope tumbling slowly through space, far from any repair shop. But a small team of engineers refused to give up on it. They found a clever workaround, using sunlight pressure itself to help balance the spacecraft, like using the wind to help steady a boat with a broken rudder. This gave the telescope a second life, and NASA renamed the mission K2. Almost nobody outside the space community noticed this quiet second chance. That underestimated, patched-together mission is exactly what found our planet. To understand how Kepler even spots a planet in the first place, think about holding your finger up close to a lamp in a dark room. Your finger does not block all the light, just a small sliver of it, enough that someone watching carefully would notice the lamp got a tiny bit dimmer for a moment. That is exactly what a distant planet does when it passes in front of its star, and Kepler was built to catch that tiny dimming, over and over, night after night, for years on end. Before its wheels broke, the original Kepler mission had already confirmed more than 2,000 new worlds circling other stars, a number nobody expected when the spacecraft first launched back in March of 2009. Even after the damage, the patched-together K2 mission went on to add several hundred more confirmed planets to that growing list, proof that a broken machine held together with clever engineering can still change what an entire species knows about the universe. Somewhere in the pile of data K2 sent home, a tiny star flickered in a way that caught scientists' attention. The dip in light was small, quick, and easy to miss if you were not looking closely. But researchers dug in anyway, and what they found hiding in that flicker turned out to be one of the strangest planets ever confirmed. The first surprise was the orbit itself. K2141b circles its star in roughly 6.7 hours. To put that in terms you already know, imagine leaving for school in the morning and the planet has already finished an entire year by the time you get home from school that same afternoon. Scientists expected a short orbit for a planet found this close to its star, but nobody expected one shorter than a single work shift. That short orbit is possible because the planet sits incredibly close to its sun, far closer than Mercury sits to ours. Being that close locks the planet in place in a very specific way, the same way our moon is locked to Earth. One side of K2141b always faces the star, forever in blazing daylight, while the other side always faces away, forever in darkness. There is no sunrise and no sunset anywhere on this world, only two permanent seasons living side by side. The second finding changed everything scientists thought they knew about rocky planets. Researchers expected the sunlit side to be hot, the way any surface facing a star up close would be hot. What they actually found was a temperature of roughly 3,000 degrees Celsius, hot enough not just to melt rock, but to boil it into gas, the same way steam rises off a pot of water left on the stove too long, except this stove never turns off, and this pot is an entire hemisphere. Compare that heat to something you already know. The oven in your kitchen tops out at around 260 degrees Celsius on its hottest setting. The day side of K2-141b runs more than 11 times hotter than your oven at full blast, hot enough that solid rock behaves the way water behaves in a kettle. And now flip to the other side of the planet, because this is where things get even stranger. While the day side cooks at 3,000 degrees, the night side sits at a bone-chilling minus 200 degrees Celsius, colder than the coldest recorded temperature ever measured on Earth. One planet, two extremes, and nothing in between to soften the difference. Scientists studying this began to wonder what actually happens at the invisible line where blazing fire meets permanent frozen dark. I want to pause here for a second and ask you something. If a planet this strange existed and you were the one who found it, would you want to shout about it from the rooftops? Let me know in the comments what part of this planet surprises you the most so far, because reading what stands out to you helps me pick which strange worlds to cover next. Let us keep going because the story gets even weirder from here. A research team led by Jiang Nguyen, a scientist working at York University under the guidance of Professor Nicholas Cowan at McGill University's Department of Earth and Planetary Sciences, decided to model exactly what might be happening in that boiling boundary zone between fire and frost. Their study was published in November of 2020 in the monthly notices of the Royal Astronomical Society, a respected scientific journal that astronomers around the world rely on. What this team discovered was the third and strangest finding of all. On the day side of K2141b, the heat is so extreme that solid rock evaporates directly into the sky, forming a thin, wispy atmosphere made not of air, but of vaporized stone. Picture the steam that rises off a hot cup of tea on a cold morning, except instead of water vapor, this steam is made of the same minerals found in the granite countertop in a kitchen. Scientists expected any atmosphere on a planet this small and this close to its star to be stripped away completely by the star's radiation, leaving nothing behind at all. What they actually found was a thin but real layer of rock vapor clinging to the day side, thick enough that future telescopes might be able to detect it from hundreds of light years away. That gap between what was expected and what was found is exactly the kind of surprise that makes scientists sit up straight in their chairs. Here is where the story turns from strange to almost unbelievable. That rock vapor does not just sit still in the sky. According to the modeling done by this research team, powerful winds sweep the vaporized rock from the scorching day side toward the freezing night side, blowing at speeds over 5,000 kilometers per hour. To understand how fast that really is, a commercial airplane cruises at around 900 kilometers per hour. These winds move roughly 5.5 times faster than the jet you might fly on for a family vacation. When that rock vapor reaches the freezing night side, it cools instantly and turns back into solid form, the same way warm breath turns into fog on a cold winter morning. Except here, instead of fog, tiny particles of rock condense out of the sky and fall back down as something scientists genuinely describe as rock rain. It is not a metaphor. It is real precipitation, just made of stone instead of water. Picture standing on that frozen night side, if a person could somehow survive there, listening to a strange, dry, whispering sound overhead as fine grains of solidified rock drift down out of the black sky. There would be no splash, no puddles forming, just a faint dusting building up, layer by layer, on ground already locked in permanent darkness. It is one of the eeriest images modern astronomy has ever handed us, but the story does not end with rock falling from the sky. Underneath all of this sits something even bigger, a molten ocean of liquid rock estimated to run about 100 kilometers deep. To put that in perspective, the deepest point in Earth's oceans, the Mariana Trench, drops down about 11 kilometers. The magma ocean hiding beneath K2141b's surface is roughly 9 times deeper than the deepest trench in any ocean on our own planet. That magma ocean does not just sit there quietly either. According to the research team's models, currents inside it slowly flow, carrying newly fallen rock rain back toward the scorching day side, where the heat vaporizes it all over again, sending it skyward to repeat the entire cycle. It is a complete weather loop: evaporation, wind, condensation, and rainfall, just like the water cycle you may have learned about in school, except every single part of it is built from rock instead of water. There is a fourth discovery buried in this research that puzzled scientists the most of all. Because that magma ocean keeps circulating, slowly carrying rock rain back toward the boiling day side over and over again, the researchers realized this cycle is not a one-time event frozen in place. It is ongoing, active, happening again right now, in this exact moment, the same way rain is falling somewhere on Earth as you listen to this sentence. Scientists expected a planet locked this close to its star to eventually settle into some kind of frozen, unchanging state, done evolving, done changing shape. What they actually found was a world still actively reshaping itself, one evaporation and one rainfall at a time, meaning the surface of K2141b today may already look slightly different than it did when this research was first published. A planet, quietly rebuilding its own face, one grain of falling stone at a time. If you let yourself imagine standing on the frozen side of that world for just a moment, picture the strange silence first. No wind on that side, no birds, no distant traffic, just the faint, dry hiss of fine mineral grains drifting down out of a black, starless sky. Then imagine turning to face the day side, where the air itself seems to shimmer and glow white, radiating a heat you could feel on your skin from 100 kilometers away. Two entirely different worlds, stitched together into a single spinning planet. Quick question for you, because I am genuinely curious. Would you tap like on this video right now if learning that an entire planet runs its own version of the water cycle using melted stone instead of water blew your mind a little? Hitting like tells the platform that this kind of deep, strange science story is worth showing to more people who would enjoy it just as much as you did. Let us zoom out for a moment before going even deeper, because there is something else about K2141b that scientists almost missed entirely. When the research team studied exactly how light and shadow fall across the planet, they discovered that roughly 2/3 of the entire world sits in permanent daylight, not the neat half-and-half split you might expect from a tidally locked planet. That imbalance comes from the exact tilt and shape of the planet's locked orbit, something researchers had to calculate carefully rather than simply assume. Think about that for a moment using something closer to home. If you split a sandwich exactly down the middle, you expect 2 equal halves. Now imagine cutting that same sandwich and ending up with one piece twice as large as the other, simply because of the angle of the knife. That is roughly the kind of lopsided surprise researchers ran into when they actually measured how daylight and darkness are divided across this tiny, fast-spinning world. This detail matters more than it might seem at first. It means the boundary between fire and frost, the line where rock vapor turns back into rock rain, sits in a different place than early guesses assumed. Scientists expected a simple, even split between burning day and frozen night. What they actually found was a lopsided world, with the frozen zone squeezed into a smaller strip than anyone had guessed. Let us talk about named sources for a moment, because this is not a random claim pulled from nowhere. The team behind this discovery included researchers not just from McGill University and York University, but also scientists from the Indian Institute of Science Education and Research, working together across 3 institutions to build and test their model. NASA's own K2 mission is what first spotted the tiny dip in starlight that revealed this planet's existence in the first place, years before anyone understood just how strange it truly was. Here is something scientists will tell you honestly, without dressing it up. They do not fully know yet whether the rock rain, the supersonic winds, and the churning magma currents are happening exactly the way their computer models predict. This entire picture comes from simulations built using the laws of physics and the limited data available, not from a spacecraft that has actually flown through K2141b's atmosphere and measured the wind speed directly with an instrument. That gap between prediction and direct proof is exactly why researchers pointed toward the James Webb Space Telescope, a powerful instrument capable of studying the faint chemical signatures of distant atmospheres in far more detail than earlier telescopes ever could. Until observations like that are actually carried out and the data comes back, The full weather story of K2141b remains our best current guess, built on solid science, but still a guess waiting to be tested against reality. Even the exact depth of that magma ocean is still debated among researchers who work on lava planets. Some models suggest a shallower molten layer sitting on top of solid rock underneath, while others support the deeper 100-kilometer figure used in this particular study. Nobody is pretending the number is locked in stone, no pun intended, and future missions with sharper instruments will likely refine it further as more data comes in from telescopes we have not even launched yet. This is normal in science, even though it rarely gets shown this honestly in movies or television. Real research is not a straight line from question to perfect answer. It is closer to slowly turning up the brightness on a dim photograph, a little more detail appearing with every new telescope, every new study, every new team of researchers willing to double-check the work that came before them. This kind of honest uncertainty is not a weakness in the story. It is actually one of the more exciting parts of it. Scientists are essentially forecasting the weather on a planet hundreds of light years away using nothing but physics equations and the small amount of light that reaches our telescopes. Imagine trying to predict tomorrow's weather in a city you have never visited, using only a photograph of its sky taken from an airplane window. That is roughly the scale of the challenge researchers are working with here. K2141b is not entirely alone in its strangeness either. Other lava-covered worlds have been found before it, planets like Corot 7b and 55 Cancri e, both known for scorching temperatures and surfaces that may partly consist of molten rock. What makes K2141b stand out from that crowd is not just the heat, but the fact that scientists were able to model an entire working weather cycle on it, complete with wind, evaporation, and rainfall, something far more detailed than simply saying a planet is hot. Let us pause on that idea of prediction versus proof for a second, because it says something bigger about how much of modern astronomy actually works. Almost nothing about K2141b has ever been touched, sampled, or measured up close. Every single number in this story, the wind speed, the ocean depth, the surface temperature, comes from analyzing tiny changes in starlight and running that data through careful physics equations. It is a little like figuring out exactly what is cooking in a neighbor's kitchen just by noticing the smell drifting through a cracked window, except the window is 200 light years wide. That is genuinely how strange and impressive this field has become. Researchers are not guessing wildly. They are using confirmed laws of physics, the same laws that explain why water boils on your stove, or why wind picks up before a storm, and applying those same rules to a world none of us will ever visit in person. The planet may be almost unimaginably far away, but the science holding this story together is grounded in exactly the same physics running quietly through your own kitchen right now. If a friend of yours loves space, weird science facts, or things that sound made up but turn out to be completely real, this is exactly the kind of video worth sending their way. Would you share this with that one person you already know would find this fascinating? Sharing helps stories like this one reach people who would genuinely enjoy them, but might never stumble across this corner of science on their own. Let us return to scale for a moment, because it is easy to lose track of just how enormous some of these numbers really are. K2141 itself, the star this planet orbits, sits roughly 200 light years away from Earth. Light travels at about 300,000 kilometers every single second, faster than anything else we know of in the universe, and even moving that fast, it still takes 200 years for its glow to reach our telescopes. That means the light researchers studied to understand this planet's temperature and winds left its star around the same time steam engines were first spreading across factories on Earth. Every measurement scientists make of K2141b is really a measurement of light that has been traveling toward us for 2 centuries. A strange kind of time capsule wrapped inside ordinary starlight. Now bring that back down to something small and familiar. A grain of table salt is about the same size as some of the tiny mineral particles scientists believe make up the rock rain falling on K2141b's night side. The very same universe capable of stretching light across 200 years of travel is also capable of producing individual falling particles smaller than something sitting in the shaker on your kitchen table. Huge and tiny, sitting inside the very same story. Let us slow down on that 200 light-year figure for just a moment, because numbers this big tend to slide right past us if we move too fast. If you tried to fly to K2141 in a commercial airplane, the same kind cruising at 900 kilometers per hour that we compared those winds to earlier, the trip would take roughly 240 million years. For comparison, that is longer ago than when the very first dinosaurs were still walking around on Earth. And that is just the distance to the star, before you even begin measuring the wild weather happening on the tiny planet circling it. Now shrink that number back down to something you can actually hold in your hand. The magma ocean scientists modeled under K2141b's surface is roughly 100 kilometers deep, but a single raindrop of liquid rock, cooling and hardening as it falls, might end up no bigger than a grain of rice from your own kitchen pantry. The same story that stretches across 200 light-years of empty space also comes down, eventually, to something the size of a piece of gravel landing on frozen ground. It helps to remember that K2141b is not some isolated oddity sitting alone in the universe. Astronomers have been slowly building a catalog of lava worlds for years now, planets like Korat 7b, first studied by a French-led space mission, and 55 Cancri e, sometimes nicknamed a diamond world because of theories about its interior composition. Each of these planets circles its star closely enough to keep at least part of its surface molten, but none of them, so far, has had a full working weather cycle modeled in this much detail. That is really what sets K2141b apart from the rest of that strange, glowing family. It is not simply the hottest, or the closest, or the most extreme in any single category. It is the planet where scientists finally sat down and asked a deeper question. Not just how hot is this world, but what would the weather forecast actually look like if you lived there? That shift, from measuring a place to actually forecasting its climate, marks a real turning point in how researchers study worlds we will likely never visit in person. Space agencies are not finished with worlds like this one either. Future observing time on telescopes such as James Webb is already being requested by teams hoping to catch the faint chemical fingerprint of rock vapor drifting above K2141b's dayside. If that signature shows up in the data, it would mark the first time humans ever directly detected a rock-based atmosphere on another planet, turning a computer model built from careful guesswork into a confirmed, measured fact. There is one more layer worth sitting with before we close this out. The heat radiating off the dayside of K2141b is intense enough that if a spacecraft somehow hovered close enough to study it directly, its instruments would need to withstand temperatures that melt not just rock, but many of the metals used to build spacecraft in the first place. That single fact explains why almost everything we know about this planet comes from distant light, careful math, and patient modeling, rather than a mission that has ever gotten close. And that brings us to a bigger question worth sitting with, one scientists are still chewing on today. If a planet can host oceans, weather, wind, and rainfall using rock instead of water, what other strange chemistries might be running quiet weather cycles on planets we have not even properly studied yet? Nobody has a full answer to that yet, and that honest not knowing is part of what makes this field so alive right now. One last question before we bring this story home. What is one thing from this video you are going to bring up the next time you talk to a friend or family member about space? Drop it in the comments, because I genuinely read through them, and knowing which single detail sticks with you the most helps shape exactly what strange planet we dig into next. So here is where we land. Nobody expected a broken, patched-together spacecraft to find one of the strangest planets scientists have ever modeled. Nobody expected a world barely bigger than Earth to run its own complete weather cycle using melted stone instead of water. And yet here it is, spinning quietly in the dark 200 light-years away, doing exactly that, whether anyone back home is paying attention or not. Think back to that very first image from the start of this video, rain falling as rock, and an ocean glowing instead of splashing. It sounded almost impossible a few minutes ago. Now you understand exactly why it happens. The heat, the vapor, the supersonic wind, the freezing night side pulling everything back down into solid form again. What once sounded like a paradox now makes complete, careful scientific sense inside your own head. That is the strange gift hiding inside stories like this one. A detail that once sounded like pure fantasy, rock literally raining out of an alien sky, turns out to be one of the most carefully reasoned predictions in modern planetary science, built by real researchers, published in a real journal, and waiting on real telescopes to confirm it piece by piece. At the start of this video, that opening image probably sounded like something borrowed from a story, rather than something sitting in a scientific journal. A world where stone falls like rain and oceans glow instead of splash felt like it belonged in fiction, not in a peer-reviewed paper written by working astronomers. That gap between how impossible it sounded and how carefully it was actually measured is exactly what makes this planet worth remembering long after the video ends. Somewhere out past our own solar system tonight, K2141b keeps spinning, completing an entire year every 6.7 hours, its dayside glowing white hot, while its night side sits frozen and silent under a light dusting of falling stone. It does not know we are watching. It does not know it has a name given to it by people on a small blue and green planet 200 years of starlight away. But we do know. We know because a broken telescope got a second chance, because researchers refused to stop asking questions about a tiny flicker of light, and because somewhere in that flicker was an entire world quietly rewriting what we thought a planet could even be. Few people have ever heard this planet's name before today. Now you have, and it is the kind of detail, once you know it, that is hard to ever fully put back down. The next time you look up at the night sky, remember that somewhere out there, past the stars you can actually see, worlds are running their own quiet weather, their own storms, their own rainfall, built from materials we would never expect. Carry that thought with you, just for tonight, and let it sit there quietly the way rock rain settles on a planet nobody back home can see.